Welcome to this explainer. So I want you to picture this for a second. You're standing right in the middle of a bustling city, looking up. Above the skyline, these dark, heavy clouds are rapidly gathering. The sky turns this bruised, almost ominous gray. The air feels thick, right? Electric with that sudden drop in pressure and the promise of an impending downpour. It's a dramatic, mysterious, and honestly awe-inspiring scene that humanity has watched unfold for thousands of years, completely at the mercy of the skies. Historically, our response to this was either to, run for cover or perform rituals. In the late 1800s, there were actually these rainmakers who traveled across the American West, firing cannons into the sky. They genuinely believed the concussive blasts would literally shake the water right out of the clouds. We've just always had this deep-seated obsession with taming the atmosphere. But what if that dynamic was finally flipped? What if those clouds weren't just a force of nature we had to endure, but a system we could actually engineer? Seriously, what if humans could actually control rain, storms, or even the weather as a whole? It sounds like absolute magic, doesn't it? Or, I don't know, maybe the plot of a summer science fiction blockbuster? But this isn't just an idle fantasy anymore. Okay, let's dive into this, because the reality of what scientists and engineers are doing right now is absolutely fascinating, and we're going to break down the actual science step by step to see exactly where the boundary between sci-fi and everyday reality actually stands. Section 1. Current Technological Reality. The Science of Weather Tech. So we're changing gears here from pure speculation to the grounded truth of our modern world. Right now, as we speak, meteorologists are utilizing actual physical weather technology out in the real world. We've already taken the very first concrete steps toward manipulating the environment above us through a process called cloud seeding. As you can see, this is a highly targeted method used to encourage rainfall under specific pre-existing conditions. And this is where the science gets incredibly cool. We aren't just shooting cannons at the sky anymore. Instead, scientists fly specially equipped aircraft directly into the base of storm clouds. These planes release a chemical compound, most commonly silver iodide. Now, why silver iodide? Well, because at a molecular level, its structure is almost identical to natural ice crystals. When these microscopic silver iodide particles are introduced into a supercooled cloud, they act like scaffolding. The moisture in the cloud suddenly has something to cling to. It freezes around the silver iodide, grows heavier, and finally falls to the earth as snow or rain. And this isn't just theoretical research happening in some lab. The United Arab Emirates, which is a country dealing with severe water scarcity, conducts hundreds of cloud seeding missions every single year. Studies suggest they've been able to increase targeted rainfall by anywhere from 15 to 30%. Over in the United States, places like Idaho and Colorado use automated generators high up in the mountains to seed winter storm clouds, purposefully boosting the snowpack to ensure rivers stay full for agricultural use in the summer. So human intervention in weather systems is not some distant dream. It's an active, heavily relied upon tool currently in our scientific toolbox that directly impacts the global food and water supply. Section 2. The AI Frontier. Prediction versus Control. So, we can coax a little more rain out of a cloud. But where do we go from here? Imagine stepping into a modern, state-of-the-art meteorological facility. We're talking a massive room where towering screens display global atmospheric data, processing petabytes of information in real time. We are entering an incredibly exciting era where artificial intelligence is fundamentally rewriting how we interact with the skies. Now, what's really interesting about this slide is how futuristic AI weather control centers are no longer just reacting to storms. Their primary function is predicting them with a level of hyper-precision we've literally never seen before. For decades, traditional weather forecasting relied on massive supercomputers grinding through highly complex physical equations, a process that could take hours just to tell you if it might rain next Tuesday. But scientists are now actively exploring how AI improves weather forecasting by completely bypassing that bottleneck. Modern AI weather models are trained on 40 years of historical, global weather data. They've learned the patterns of the atmosphere so well that tools like Google's GraphCast can now generate a highly accurate 10-day global weather forecast in under 1 minute on a standard desktop computer. It is a staggering leap in our forecasting capabilities. But there's a very firm boundary here that we must acknowledge. Fully controlling the weather is not currently possible. We are getting unimaginably good at predicting the sky, but total command over it remains entirely out of reach. And this brilliantly illustrates the massive canyon between AI storm prediction and full weather control. On one hand, human ingenuity and machine learning have combined to give us unprecedented foresight. We can map out a hurricane's trajectory days in advance, saving countless lives and billions of dollars in infrastructure. But on the other hand, the ability to literally summon a storm to end a drought or banish a hurricane before it hits a coastline, that involves overcoming physical barriers that are frankly mind-boggling. To understand why this is so difficult, you have to think about the sheer thermodynamics of weather. A single perfectly average hurricane releases the energy equivalent of a 10-megaton nuclear bomb exploding every 20 minutes. Every 20 minutes. You can't simply build a machine or deploy a fleet of drones to just turn off that kind of raw kinetic energy. Furthermore, the atmosphere is the ultimate manifestation of chaos theory. The famous butterfly effect, the idea that a butterfly flapping its wings in Brazil can set off a tornado in Texas, that is a very real concept in meteorology. The atmosphere is an incredibly sensitive, globally interconnected fluid system. If you try to aggressively push one part of it, the ripple effects are entirely unpredictable. So, while AI gives us a high-definition, real-time map of exactly what the atmosphere is going to do, it doesn't give us a steering wheel. The physical energy of the Earth's weather system is simply way too vast for us to overpower.
Section 3. The Ethical Dilemma, Power and Trust.
As our technology steadily advances from simply predicting storms to real-world methods like cloud seeding, we really have to pause and consider the immense weight of what we're doing. Engineering our skies isn't just a scientific or engineering challenge, it is an incredible geopolitical responsibility. Would you trust humans to control the weather? I mean, really, think about the sheer pragmatics of that kind of power. Weather doesn't respect national borders. The atmosphere is a shared, continuous blanket around the globe. If one country decides to heavily seed clouds over its own territory to end a localized drought, are they effectively stealing moisture that would have naturally fallen on a neighboring country downwind? If you have the technology to divert a catastrophic storm away from a wealthy metropolis, do you accidentally push it toward a vulnerable farming region instead? When you start talking about altering immense natural forces, you inevitably have to talk about power, accountability, and who gets to make those decisions. It's a massive, complex issue, one that is only going to get more pressing as our atmospheric technology evolves in the coming decades. Because once we figure out how to play God with the sky, we have to figure out who gets to hold the remote. Thanks for joining this explainer.